In this detailed example, we're going to look at linear regression using Excel, and we're going to use the random sample of 20 cases from the 2012 General Social Survey. And so notice here that I've already taken only those two variables that I'm going to work with here. Father's education is going to be my independent variable, and response education is going to be my dependent variable. And notice that I'm including the scatter diagram that we created in the detailed example that dealt with covariance and correlation. Let's suppose that I wanted to create the linear regression line that best fits these data. Well, how would I do it? Well, first of all, I need to calculate some additional statistics. One statistic that I have to calculate is the covariance of the two variables. And although we did this by hand in a prior detailed example, we can actually use a built-in function, covar, that basically takes data from two separate variables separated by commas and automatically calculates the covariance. So Excel calculates this covariance to be 3.13. And so remember that we got a slightly different value when we calculate the covariance by hand. And the difference is due to the fact that Excel uses the formula for the population covariance. That is, it uses n instead of n minus 1 in the denominator. And so we can actually take this calculation and modify it so that it doesn't calculate a population covariance, but instead calculates a sample covariance, which is one that we want. So we're going to take this value and multiply it by the number of cases, 20, and then divide that by the number of cases minus 1, or 19. And we're going to get something a lot closer to what we calculated previously, 3.29. Now we also need to get the variance of the independent variable to calculate the slope. And the independent variable, again, in this case, is father's education. And so that comes out to 8.43. Now, to get the slope, all we have to do is we have to divide the covariance by the variance of the independent variable. And so we get a value of about 0.39. And from the slope, we can actually calculate the intercept. So the intercept is going to be equal to the average of the dependent variable, which again is education, minus the product of the slope and the mean of the independent variable, father's education. So we'll close the parentheses, and Excel calculates a value of 9.13. And so we have both the slope and the intercept for our linear regression equation. And so what do these things actually mean? Well, recall that the slope tells us the predicted value of the dependent variable for every unit increase in the independent variable. And so in this case, if we increase the value of father's education by 1 unit or 1 year, this model tells us that we increase the value of response education by just over 1/3 of a year, specifically 0.39 years. So every unit increase in father's education, every year increase in father's education yields a 0.39 increase in the predicted value of the response education. And then the intercept is the value of the predicted value of the response education when father's education is set to 0. And so for someone who has a father's education at 0, that person is predicted to have a little over 9 years of education, 9.14 years, let's say, if we round it. Okay, the next thing we want to do is we want to figure out how well our model fits our data. So looking back at the scatter diagram, well, we can see that we can probably fit some kind of a linear line to this relationship. And so if we graph these values, that would be the line that best fits the data. And so we can actually add a line to these data. What we do is we just highlight the series, and then we right-click, and then we add trend line. And if we add a linear trend line, which is the default, that's going to get us the linear regression equation, or something really close to it. And so we'll click close. And notice that we now have basically a line that shows us the linear trend, the relationship between these two variables that's predicted by a linear regression line. And so it at least looks like it has a fairly decent fit, but we need some kind of a formal test for how well these things actually fit together. And so what we would calculate is something called the R-square. And so remember, the R-square is a measure of model fit. And in order to calculate R-square, we first have to calculate the variance of the dependent variable. So again, we can use Excel's built-in var function, and we want to get the variance of our dependent variable, education in this case. And that comes out to about 7.25. So now we can calculate the R-square by taking the covariance the sample covariance, squaring it, making sure that we put it in parentheses, and dividing that value by the product of the variance of the independent variable and the variance of the dependent variable. And we get a value of about 0.177. Let's say, with rounding, 18%. So what does that mean exactly? Well, it tells us how much of the variance in the dependent variable is explained by the independent variable. So in this case, about 18% of the variance in education is explained by father's education. Now you might be wondering, why is it so low? Well, there's several other factors that determine how much education a given person gets. And father's education is just one factor among many factors we could consider. So there might be things like age or socioeconomic status or race or sex or something like that that also relates to education that we're not capturing. And so this single factor accounts for about 18% of the variation. But if we added more factors and we made a multiple regression model, we would probably have a better fitting model than the one we have right now. Now remember that we can also calculate the coefficient of correlation from the coefficient of determination, r squared. And so to calculate r from r squared, we would just take the square root of the r squared. And we get a value of 0.42. So again, that tells us that there's sort of a moderate relationship, and it's a positive relationship between father's education and respondent's education. So that's a fairly robust relationship, although again, there's probably a lot of other factors that relate to the respondent's education other than just father's education. But this seems to have like at least a moderate fit.